Good morning. Today we see in code in Python code to generate a zoom of particular fractal, say Julia fractal. We call this particular Julia fractal as dragon Julia fractal for the shame of a figure. Okay, we start with we started the code with the import of a library. There is the import NumPy, where NumPy is the standard library for doing EV math and data crunching in Python. After there is my Matplotlib, where is imported the library to plot, to use to create static animated interactive visualization in Python, and after the specific color to to code the color to generate to handle color maps and data normalization. OS is another library che interact with computer operating system type Windows, MS-DOS or Linux. Is a module that lets your code interact with the computer operating system. After define and in the line 42 define a function, the main function to generate the zoom. In there is a print to start to indicate the start of sequence. In the 46 there is a variable determine the total number of image, the frame, that the script will generate, which shows in this case 200 frame. After there is a zoom factor, put equal at 0.85. What mean che the zoom each frame will be 80% of the size of a precedent frame. So we clearly put one. The zoom is there isn't no zoom. Is the dimension of a frame is equal of precedent. Center x, center y is the coordinate in x and y of in the complex plan that the camera will zoom in on. Base width 3.0 and base 82.0. See the initial dimension of viewing window for the very fast frame. After define the parameter fractal, define the complex number constant used to the shape this specific Julia set. The mathematical formula we remember is Zn plus 1 is equal to Zn elevated 2 plus the constant we defined before. N is set up the resolution image. Is in this case is image 5000 for 5000. So is necessary much time to generate this image for numero of a frame equal to 200, but give an very good resolution. Max iteration the maximum number of time the math formula will run per pixel. Higher number reveal more detail, a deep zoom, but take longer to compute. Escape radius is a threshold value. If a pixel value exceeds this number during a calculation, it has escaped to infinity and the loop stop for the pixel. Autodir is the directory where we save the frame, the frame image we generate in the zoom. OS point make dirs output dir. Create this folder we called before, and we put exist okay equal true argument prevent the script from crashing if that folder already exists. We reiterate the code, and we have generate in precedence the folder will not crash the code. Okay, after K there is color. Here with the color map with the different color we see when generate red, yellow, green color, and is a palette used for the construction of image. Dragon Map convert the raw list of color in the Matplotlib color map. The object can be applied to the data. So colors here is put here and convert the raw list we see here. After there is the main rendering loop, there is the for. Start the loop will run with the first frame for the total own number of frame. Here it's possible, okay, the print the current progress of generate of a frame. In the line 81, calculate the width for the current frame. The power operator ensure the zoom compound exponentially. The same for current 8. You take we see the present value, and after multiply for the zoom factor 0.45 and elevate for the number of frames, so 1, 2, 3, 4, and so on. After calculating this, it's possible to calculate x min, x max, y min, y max, where calculate the window in x, y of image of the frame of a frame 1, 2, 3, or 4. After generate the complex plan for this frame, x equal np ln spine, create an array of n number, create the n number, the type float, so the five 500 pixel, and with the coordinate x min and y min in this case. After x y equal NP Matplotlib, combine the x y array in two grid representing of pixel of image. In zeta merge the x y calculate into a single grid of complex number. The x-axis represents the real part, and the y-axis represents the imaginary part. You see in the Python J is I in the imaginary, in the in the plan, imaginary plan. In the line 95, output equal np.0, create a blank array to store the final color value for each pixel. Alive equal np1.1 like zeta, create a mask array of true value, tracking which pixel have not yet escaped the threshold. Here there is the iteration, the math iteration. For E in range max iter, start the core fractal calculation, looping up to 500 times in the year. With okay, suppressed warning for the mathematical overflow, which are expected when calculating the number shooting of the infinitive. Zeta is the zeta live equal zeta live elevate 2 plus C is the equation of imaginary equation of fractal. Escape, check with the pixel just crossed the threshold during the specific loop. Zeta escape equal a zeta escape, isolate the value of those newly escaped pixel. There is other, this formula is in formula to smooth shading. Instead of coloring band based on pure integral, this uses logarithm to calculate the fractional escape time, creating smooth color gradient. And alive, update the alive mask to remove the pixel that just escape. So they are not calculated in the next loop. Finally, output alive equal a max iteration for any pixel that never escape after all 400 loops. Assign the maximum volume, usually colored black, or the end of a color map. After there is the plotting the plotting code. Allora, plotting figure define create a blank 8x8 Matplotlib canvas. Plot in show in show takes the mathematical output grid and draw it as an image. It apply your custom dragon map and use empower norm to adjust the contrast gamma for the colors. Plot axis equal off, plot axis put off. is hide the x and y axis and the number. This code remove and whiteboard around the image, and after save the generate in the generate image in frame with the count 1, 2, 3 or 4 in PNG image, and close the plot. When finish all the loop, okay, print this value. So we not start the code, but we see the finally solution, well, finally frame we generate is similar or this. Okay, it's a 200, and finally we 200. So depend on clear computer, we take time to generate this frame with and we see this some frame is the zoom respect of present frame. Okay, so I stopped with this first program. We start with other program where we will take the frame put in the dragon in the dragon zoom frame and generate an video MP, the type of MP4. Okay, we start before to explain the code. We start with the import library. There is the import CV2, import OpenCV is a tool for image and video processing. Import OS we see is import the operating system library to interact with the folder and file. Import array, import the regular expression library, which is used here to find the number inside the text string. Okay, define the function, the main function. There is we indicate the folder when find the frame generate with this code, and then we name the finally directory where the director file of in MP4. FP equal this, set the frame for second. In this case is 1050 FPS. What mean 2 under the frame will result in 20 second frame. Image in the line 46 image is look inside the target folder and create a list of every file in the end with PNG. Image sort, this is a crucial step. Computer naturally sort alphabetically with the means frame. This PNG will incorrectly appear before frame to PNG. Design use regular expression array to strip away to the letter, leaving only the number, and sort the list numerical so the frames stay in the exactly order they were generated. Okay, if not image, check if the list image is empty. Okay. For 54, first image path equals path, get the exactly 5 path to the very first image in the list. First frame equals cvdue, tell OpenCV to open and read that first image. If the first frame is none, a safety check in case of image file is corrupted or unreadable. Okay, and after 61, target 8 target width, extract the pixel dimension 80 and width for the image. The underscore ignore the color channel data, which we don't need here. All feature frame must match this dimension exactly, or OpenCV will fail write the video. Okay, after there is the setup video, the setup of video writer for CC equal CV2 video writer for CC. Define the video code MP4V in standard for rendering MP4 video files. And video, this code initialize the tool that will create the video. It gives the file name, the code, the frame rate, and the exactly canvas size it needs to expect it. Unzoom image, this created the zoom out effect. It takes the list of image and reverse it. The syntax is next trick is start the second to last image and work out backward. Skip the very last image so the video doesn't have duplicate frame rate and the maximum zoom peak, which would look like a sudden stutter. After okay, after okay, there are for count okay, no, okay, in the 69 combined the forward zoom in sequence and the backward zoom out sequence into one massive master list. Okay, after we can see the for, and for count, start a loop that goes through every single file in the master list, enumerate, keeps running totally count, so we know what frame number we are currently process. Image path, create the exactly file path for the current frame. Frame equal CV2, tell OpenCV to read this image in memory. This, if the frame is known, another subtly check if a specific frame rendered poorly in the first script, this prevents the entire video script for crashing. Okay, print the warning here, and current height width, check if the current frame size differ from the first frame. OpenCV is incredibly strict about this. If a frame is even 1 pixel off, the video writing process is silently break. So it's necessary to check the all frame is equal dimension. After there is the if check if the current frame size differ from the very first frame. OpenCV is incredibly okay, strict about this. Okay. Frame CV2. If the frame is wrong size, this forcefully resides to make the expected dimension. And video write takes the verified properly sized image and permanently holds in the next frame. If count equal count plus 1 divide for 15, a progress tracker, the model operates percentage check if the current frame count is multiplied for 15, and after there is the print. Okay, video release, this is point critical, site critical. It tell OpenCV are done adding the frame. It can finally compile, close, and save the MP4 file to the hard drive. Without this line, the resulting video file will be corrupted and unplayable. Okay, in this case, we can see what happened when run this code, and this is the result. You see, we start with the zoom in the internal Julia fractal, and okay, and after return in the present in unzoom the drawing, the fractal, and return in source fractal. Okay, we can start another way. Is a good resolution, and okay, we can change clear the center of camera and have the different and we can realize different video to see the different point of fractal. Okay, thank you. Bye.